Properties of sound. Sound pitch. It is a property by which the ear can distinguish between rough and sharp voice. Activity 1. Illustration of the concept of sound pitch. The high-pitched sound is sharp, soft, while the low-pitched sound is rough, harsh. The voice of women is high-pitched, sharp, has high frequency. The voice of men is low-pitched, rough, has low frequency. Determining the pitch of a tone using Savart's wheel. Savart's wheel used to determine the frequency of an unknown tone. Steps. Listen to the tone you want to determine its pitch till your ears get used to it. Start rotating Savart's wheel. At the same time, one of the gear teeth will come in contact with a flexible metal sheet. Start increasing the speed of rotation till you hear a sound similar to that of the unknown tone. Calculate the number of turns, cycles, taking place in a specific duration, and by knowing the number of teeth of the gear, you can determine the frequency of the tone by the relation. Sound frequency equals number of cycles over time in seconds times numbers of gears teeth. Frequency equals number of cycles divided by time times numbers of gears teeth. Number of cycles equals frequency times time divided by number of gears teeth. Number of gears teeth equals frequency times time divided by number of cycles. Time in seconds equal number of cycles times number of gears teeth divided by frequency. Do you know? The sound of the pitch of the siren of the fire engine increases gradually as it approaches you and decreases suddenly as it moves away. That is due to the apparent change in the frequency of the produced sound. This phenomenon is known as Doppler's effect. Sound intensity. It is the property by which the ear can distinguish between sounds either strong or weak. The measuring unit of sound intensity is watt by meter square. The measuring unit of noise intensity is decibel. Factors affecting sound intensity. The distance between sound source and ear, the amplitude, the surface area, density of medium, the wind direction. The distance between sound source and ear. Activity 2. Identify the effect of the distance between the sound source and the ear on the sound intensity. Steps. Stand in front of your maid who's supposed to make a sound of a certain tone. Move away gradually from your maid. What do you notice? Observation. The sound intensity decreases. Conclusion. As the distance between the sound source and ear increases, the sound intensity decreases and vice versa. The inverse square law of sound. The intensity of sound at a point is inversely proportional to the square distance between the point and sound source. The amplitude. Activity 3. To identify the effect of the amplitude of the sound source on sound intensity. Steps. Fix one end of a ruler on the edge of a table by your right hand. Pull the other end of the ruler by the other hand and then set it free. What do you observe regarding sound intensity arising from the vibration of the ruler? Conclusion. The sound intensity decreases by decreasing the amplitude of the vibration and vice versa. Sound intensity is directly proportional to the square of the amplitude of the vibration of sound source. The surface area. Activity 4. Identify the effect of the area of the vibration surface on the sound intensity. Conclusion. When the area of the vibrating surface increases, the sound intensity increases. The medium density. Activity 5. To identify the effect of the medium density on sound intensity. Sound intensity increases by increasing the density of the medium, and vice versa. Sound intensity is directly proportional to the density of the medium where the sound travels. Wind direction. The sound intensity increases when the sound wave propagation direction is in the same direction of wind and vice versa.